Hi everyone, Senan the side, and this is the second video in the Doubly linked list series where we are actually trying to insert an element. So in our first video, we discussed how to insert at head. In this video, we are going to see how to insert at a tail in any given Doubly linked list. And the next video, it would be at any position. So let's get started without wasting any more time. So this is, let's say, your linked list. So the next pointer, previous pointer, something like this. So what I would do is I'll just draw the blocks and assume that there is the separation between them. So let's say this is our linked list and our doubly linked list. So these are the pointers that are actually pointing to the next and the previous, and this previous is pointing to null and this is pointing to null as well. This is our doubly linked list for the given example. Now what you would be given is the head itself, and you need to add a new element, let's say with a different color, say pink. So what you need to do is add this element, this pink element, to the end of this singly linked list. Okay, so now to add this after this element, I need to reach here. That's one thing. So okay, we first need to figure out to reaching this last element, and then we'll try to do the insertion and the reassigning of the links. So let's say we are already at this node, right? We are assuming that we have reached this node. So the structure would look something like, we have this node here, we have this new node, this pink node with us as well, and this is pointing to null, this is pointing to null, as well as this is pointing to null, and this is pointing to some previous node, which is none of our concern. So we are exactly at the last node in the given linked list, and we need to add this list or this element, this node at the end. So a couple of things. First, we need to assign these links, this white link and this pink link. That's one thing, and that's it. There's nothing more to be done, because the last node, the next of the last node of this new list, is already pointing to null. Whenever you create this new node, it would be by default it would be pointing to null, and that is how I'm assuming you are writing your constructor as well. So after that, what you need to do is you take this pointer, remove this from the null and point it this node. Then you take this link from the this new node, the previous link of this new node, and you point to this last node of this original linked list. And after you're done with that, you're done. You've actually added your element to the linked list. So in this above diagram, this would look something like this. The previous would point to this node, the next would actually point to this node, and the next of this is null. So that is the way that you actually add to the element at the end. Now how do you figure out that in the original linked list which node is the last node? And that is simple. Given this node, if you check if its next is actually equal to a null node, we know we are at the last element. That's it. So what we have to do is perform a while loop. Now another case that you must be wondering, what would happen if there is no list, it's a null list. So in that case, if you add at the end, it would be same as adding to the head. So in that case, whenever you create a new node, and if the head is already null, what you do is you just say that this is the new head, and you finish with that. Okay, so let's write the code for this. So insert at tail. So inserting at tail of a linked list. So what you would be given is this head, and you would be given a value to which this value is what is needed to be added to the end of this linked list. Okay, so what is the very first thing that you would do? Let's assume that we would be returning the head of this new linked list in this. So first, whenever you are inserting an element in a linked list, regardless of it is at head, tail, or in the middle, you need to actually allocate memory for that. So let's create a new node. Let's say node star new node. This is what we allocate a new memory for it of this node class and initialize this with a value. And we assume that this constructor, this parameterized constructor, would actually point the next, would actually make the next and the previous as null. So that's one thing. Now the cases. So let's do with case 1 where list is empty, right? So in this case, what you do is you check if head is actually equal to null. That means whatever the new node is the new head. So what you do is you say this head is now this new head, or sorry, not new head, but new node. And then because we are returning the head of the linked list, you just return the head pointer. And after this, you just close this if block. Now this was the case when the list is empty. Let's look at case 2. List is not empty. So what do you do in that case? You need to traverse the list. So what I do is I take a temporary node and I point to same as the head of the linked list. Now I have to do the traversal, right? So I'll do the traversal using a while loop because I don't know how long is the list. And that is the reason why I cannot use a for loop. So let's say there is some condition in this while loop, which we will write later on. And I'll say that temp is equal to what? Temp's next, because we are trying to traverse this list. Okay. So while what? When can we actually perform this? So if you see, we are actually trying to use temp and access the next pointer of that. So if that is the case, that means temp should be a valid node. And if temp is a valid node, that means while temp, or basically this temp should be a valid node because we are trying to reach the last node. So this temp.next should also be a valid node. So while temp's next is not equal to null, what we do is we traverse this list, right? So while temp's next is not equal to null, we traverse this list. Now, in the very first iteration that you would go inside this while loop, temp would be head. Now we are trying to say temp's next. So what if head is null? This would cause an error, right? But that won't be the case because if head is null, you would have returned beforehand. So whenever you are going into this while loop, this temp node would actually be a valid node every time. So this won't cause any issue. Now, after doing this, my temp would be at a position which is the last node of this original linked list. Now we need to add this new node. So what I'll do is I'll just assign the links. Temp's next would be what? Is this new node, and this new node's previous would be what? It would be the temp itself, and then you just return the head itself. So that is the solution to this. Okay, so let's just go over it one more time. You create this new node, and while list is empty, if list is empty, what you do is you assign this new node as the head and you return that head. Otherwise, if list is not empty, you take a temporary pointer, you traverse till the last node of the list, right? Temp's next is not null. So when temp's next is null, that means we are at the last node. So at that point, we would break out of this loop. So when we are at this position, this temp is actually the last node in the linked list. And just after that, you just reassign the links like this and you return the head. Now, if you observe, all of these are what? All of these are order 1 operations. So my time complexity is order 1 and space complexity is also order 1. Same reason as inserting at head, because we are only allocating a space for a single new node. So that is the thing. But the time complexity is not order 1, sorry, because time complexity is order 1 for inserting at head. And if you try to insert at tail, right, when you're trying to insert at tail, you are actually going through this while loop. And since you're going through this while loop, it won't be order 1, it would be order n, because you would be traversing the whole list. So if list is of size 2n, you would traverse, or you would jump in this while loop 2n times, or 2n minus 1 times. So that is the thing. So yeah, time complexity is order n, space complexity is order 1, and that's it about inserting at tail. So in the next video, we'll see how to insert at any position. And yep, that's it for this video, and I'll see you in the next one. Bye.